use our equation for our parent function when we're talking about our absolute values. So remember, our absolute value graphs always look like the V, or upside down V. It has like the V-shaped graph in our equations. F of x equals the absolute value of x. So remember, the word parent function means no transformations. So remember, this is what that function's looking like with no transformations. So let's look at an example here. With this graph below, where is our vertex in this graph here? Yep, 1, -3. Remember, your vertex is this maximum, minimum points, kind of like that tip of your graph. So your axis of symmetry is this vertical line that splits your graph in half perfectly. So what's that equation for our axis of symmetry? Good. X equals 1. Remember, it's a vertical line, so it's an x equals equation. So your parent equation, remember, parent equation means no what? What was that? Yeah, no transformation. So it's just the absolute value of x. So looking next, what is our domain here? Yes, -infinity to positive infinity. And what about our range? From where to where? Negative what? -3 to infinity. So with -3, what should we have? A bracket or a parenthesis? Good, a bracket, because you do touch there. So what do we have? Do we have a maximum or a minimum point? Minimum, and it's located where? Good, 1, -3. So notice your minimum is that same as your vertex. And then next, let's talk about increasing and decreasing. So as we travel left to right across our graph, what are we doing first? Decreasing. So we're decreasing from where? That's all the way at the edge of my graph. -infinity to where? 1. Good job using that x value. If you draw your axis of symmetry, remember you just will travel right up to your x-axis. So I go from -infinity to 1, and what do I always have to use with good parentheses? And I wrote that for increasing. Remember, that was decreasing. And then, so we're increasing now from where to where? Good, 1 to infinity. Our x-intercepts are at what two places? -2 and 4. So remember, I write those as ordered pairs. So -2, 0, and 4, 0. And what is our y-intercept? Good job as an ordered pair. 0, -2. And then zeros are the same as what? X-intercepts. But remember, we write that x equals. So x equals what? -2, and x also equals 4. Do we have asymptotes here? Nope. So our end behavior, so as x goes to positive infinity, what side of the graph are you looking at? The right side. So if I'm looking at the right side, notice, oh, I'm done here. So if I go to the right side, think about I go to the edge of my graph. If I'm touching the edge of my graph, what is this doing? It's going where? Up to positive infinity. And now as x goes to negative infinity, where are you also going? Positive infinity. So with absolute values, another thing is, think about you'll have your v, right? So if it's a v, it should always be going up and up. So positive infinity, positive infinity. If it was an upside down v, it's going down and down. So that would be negative infinity and negative infinity. So note with absolute value, these should be the same. V up to positive infinity, upside down V, both down to negative infinity. So let's check out this graph down here, graphing this example below. So we have an absolute value function. So once again, what's the shape of that graph?
A V.
A V, that's great. So I have zeros at -3 and 3. So we know my graph crosses my x-axis at -3 and 3. Look at what happened next. my end behavior is described as x goes to positive infinity, y goes to negative infinity. So on the right side, should I be going up or down? Down, good. And then I'm also going down to negative infinity on the left. So is this a V or an upside down V? Yeah, so I know this is my general shape, that upside down V. So from here, to find that vertex, I'm just going to keep going. It didn't say anything about a stretch or a compress, so you can assume that there is not one. So where is our vertex located? At what point? 0, 3. So let's talk about what this equation is going to look like now. So now I can say f of x is equal to, so I used to use that f of x notation with parentheses, but now I'm going to straight up use what my function is, which is a absolute value function. So thinking about that, what transformations do I have looking at this graph? What's one? Reflect over the x. How can I show that in an equation? A negative out in front. Good. Remember, that shows my reflecting over my x-axis. And what's my other transformation? Up 3. How can I show that? Plus 3 should go inside with absolute value? Yeah, good. Outside. It's the same thing from before. Remember, if you're going up and down, it's outside. Left and right will still stay inside. All right, so let's move on to the next page. So our transformations, once again, same type of deal from before. Let's look at this first one together. So before I write my equation, let's list the transformations. So what transformations happen here? Right 4. Did anything else happen?
No.
No, so thinking about my equation, we have f of x would be equal to, how can I show I'm going right 4? Good, x minus 4, and it should go all inside my absolute value. Think about those absolute value signs as just like your parentheses from before. What's our domain here? Good. Negative infinity to infinity. Does anybody notice a pattern yet? Yeah, your domain when you have absolute value is always going to be negative infinity to positive infinity. What about our range? What is our range for this graph? 0 to where? Good. What do we have with 0? Bracket. 0 to infinity. And our vertex is at what point? 4, 0. And AOS stands for axis of symmetry. So what is that equation? Good. X equaling 4. So you guys all have time to work after, if you haven't done this part yet. So you will finish those like 2 and 3 problems on your own. So let's jump down to graphing one. So let's think about when we're graphing, thinking about your transformations and then graphing it from here like we kind of did last unit 2. So what transformations do we have? What does this 3 out front do? Stretch, good. What does this minus 1 inside do? Good, so I know I'm going right 1. And what does this plus do? Good, so let's think about putting that vertex point down first. Where does your vertex always start on your parent function? 0, 0. So let's think from 0, 0, I'm going right, how many? 1, and then I'm also going up 2. So what's my new vertex point? 1, 2. And then I now have a stretch of 3 that I want to represent. Remember, stretch was similar to slope. So if my stretch is 3, how can I get a new point? I can go where? Up 1, 2, 3, and then I can go right and left 1. So you guys are gonna, we're just gonna go through a few problems, and then you guys will have the rest of the class to finish the packet. Do we have any questions on graphing them
No,
so
ma'am.
far? Okay, so let's move on to now what is it going to be like when instead of an equal sign, it is an inequality. So if you remember from good old Algebra 1, you graphed our linear inequalities, and it was just like graphing a line. So this will be just like graphing an absolute value, but what's different is what your line might look like and where your graph is going to be shaded. So remembering from here, thinking about this equation, where's our y-intercept? Y-intercept of what? -2, and what's our slope? -2. So think about kind of like your y equals mx plus b, but you didn't have an equal sign here. What sign would you be using if you have this solid line and you're shaded below your graph? Yeah, that less than or equal to symbol. So this is going to be similar. The similar type of idea of like what your line would be looking like and how your shading would also occur when you have your absolute values. So when you are less than and greater than, what does your line look like? Dash. Yeah, that dashed line. What about if you are less than or equal to and greater than or equal to? So what type of line? Solid. Yeah, remember this stuff? Did you say it was terrible?
Yes.
Was the shading just too much for you?
Yes.
Oh man. Alright, so what about if we have a less than or equal to? Now we're getting into shading. What do these two have in common? Where are they shaded? Yeah, they shade below. What about for greater than or equal to? Where are those two shaded? Shade above. So same thing is going to be true for your absolute value. But now for your absolute value, it's not a line, it's a V. So you're either being shaded like either inside or kind of inside the V or outside. And we'll go over an example or two. So let's go over example 1 here. Remember, first we're going to graph it just like we're imagining it having an equal sign. So thinking about our transformations, thinking about where we're going right and left, up and down first. So where's this +1 taking our graph? Left 1, and this -3 is making it go 1, 2, 3. Yep, down 3. So where is our vertex? Our vertex is at what point? -1, -3. So now I want to think about that stretch. We have a stretch of 2 here. So how are we getting our other points? We're going up 2, then over 1 in each direction.
Wait, what?
What?
Okay, no, never mind.
Alright, so before I make my line, I'm going to pause and think for a second. What inequality are we dealing with here? Greater than. Okay, so what should a greater than line look like? Should it be dashed or solid? Dashed. Good. So I'm just going to dash my line all the way through. And then, now let's talk about shading. Where should I shade? Above. So if you're confused on where to go, put your pencil on your vertex. And if I'm shading above, I'm going to just put my pencil straight up. So this is my area. I'm shading inside here. So let's talk about what if this was a less than symbol. You would have to shade everywhere below this V shaped here. So this whole area below would be shaded. Basically, that would mean anything not inside it. Any questions on the graphing? Okay, so this is what now we're going to talk about writing an equation. So we are past Algebra 1. We're not looking at linear graphs, so we can just, we're not going to look at those two. So let's look at A together. So we are going to write an inequality for this. So thinking about my graph will look like f of x. So let's think about what inequality symbol should we use here if we have a dashed line and we're shaded below. I already heard it. What was it? Less than. Good. We have a dashed line, we're shaded below, so therefore we're using less than. So now I want to keep thinking about the rest of my equation, right? Oh, what was that? We do have a compression. So let's figure out what are we compressing by? So almost. Notice we're going up by 2. So think about I'm here. My other good point I think is right here at that point 8.2. So I'm going up 2. And then I'm going over how many if I'm at 3 and then I'm moving to 8?
Why would you go up to?
Because look on your graph. This space here represents a factor of 2.
Oh.
You see that?
Yeah.
So this one jump, even though it's like one block, was actually saying I'm going up 2 and I'm going over 8. So I was at 3 and then I went, over 5. I was at 3, I went over 5 spaces to get to 8. So we're compressing by 2/5. So did we go to the right or to the left? To the right by how many? 3. So what should be inside with our
-3?
good -3? And do we go up or down? No. So that is about it. All right, so if you could just flip to the last page. All right, so we are not going to super go over inverses a lot, but since we've already talked about this unit, let's just go over that idea one more time. So remember, we have our parent function, that V-shaped graph, that's our absolute value of x. So we're talking about what would this inverse look like? So how could I find an inverse? What could I do? What's one idea we talked about with finding inverses? What does that mean? Switch what? The x and the y, right. So let's think about if I have like this point right here, 1, 1, that would say 1, 1, right? 2, 2 would say 3, 3. So these all up and down, this are going to stay the same. What's really going to change are probably these points right here. So if we're at -1, 1, if I switch my x and y, what is that now going to become? 1, -1. Same thing here if I'm at -2, 2. If I switch my x and the y, what's that now going to be? 2, -2. So it's going to be, the inverse is going to look like this. Oh, yes. So what do we notice about this inverse? Is it a function? No, it is not a function. How do we know these are inverses? How do I know
Because the
graphically?
linear linear line and then that's
It reflects off of what linear line exactly?
y x equals
Y equals x. Yes, this line right here, that line y equals x, you are reflecting over y equals x. That's how you know they're inverses. Good. So just to review from that first day, reflecting over that y equals x. Alright, so from here you guys are just going to keep working for the last moments of class on finishing that. So remember,